Okay, lesson 5.4, we're going to be solving some special systems of linear equations. And this is what we mean. So this is what we've been working with up to this point. We have two lines on the graph, and the place where they intersect right here is the solution, okay? There's one solution. There's only one place where those two lines intersect. One thing that we'll know about these two lines is they have some common attributes. They're going to have different slopes for sure. Now, they don't always intersect at perpendicular lines, so don't worry about, determining if they're perpendicular or not at this case. Just knowing that if you look at them in slope-intercept form and they have a different slope, at some point they will intersect, okay? Next up is no solution. When there is no solution, the lines never intersect. And the two lines that we know on a plane or anywhere that will go on infinitely long forever without crossing are parallel lines. So in slope-intercept form, when there's no solution, they have the same slope. So these are very easy to identify, right? So if you have the same slope, you know there's going to be no solution. No need to graph it. No need to use substitution or elimination, and so forth. But then the last one, infinitely many solutions, and you might think, oh, there's only one line here. Well, the reality is there's two lines, but they're overlapped perfectly because the lines are the same. So if you're looking in slope-intercept form for infinitely many solutions, it will be same slope and same y-intercept. Everything is the same. So we'll look at a couple different things, and we'll attempt solving them as well, so that we can see what it looks like when you have no solution or infinitely many, because those are the two new ones. All right. So if you're asked to solve the solution, in this case as solving a system with no solution. So this is in your textbook, which you don't necessarily have a copy of, but you can always access it online. You can solve by graphing, right? They're already set up in slope-intercept form, so that's a quick and easy way. But look at this. Just upon inspection, they both have a slope of 3x. What we know about parallel lines is that parallel lines have the same slope. When they're parallel, they will not intersect. When they don't intersect, there will be no solution. So, that's really all it boils down to. So there's no need to really spend much time talking about that. Solving the system. So let's inspect them. They're in slope-intercept form, remember. Okay, so looking at the slope. Here, slope of -1, slope of -1. Do they have the same y-intercept? No. So in this case, we would say there is no solution. And the reason is parallel lines. Same slope. So through inspection, we were able to tell that. Looking at number 2. So at first thought, these are set up to go ahead and substitute in. So let's go ahead and do that, because, we're not always going to, put them in slope-intercept form to see what's going on. So let's solve this. So in the second equation, we have 5 times x plus this negative 5x minus 2 is equal to 0. So we have 5x minus 5x. They cross each other out, right? They cancel each other out because it's equal to 0x. So -2 equals 0. Does -2 equal 0? No. -2 does not equal 0. So this is another example of no solution. Okay. If we would have maybe taken this one and put it in slope-intercept form first, right? So we would have y is equal to -5x plus 0, right? You don't need the 0. So knowing that it has the same slope would be another way. So if you want to put it in slope-intercept form, that's another thing. I'm going to just keep continuing with the substitution method, because you're at the point now when you're solving systems, you always kind of look for the easiest way to solve it. Since one equation is solved for one of the variables, substitution tends to be the easiest way. So 2 times 2y plus 10 plus 3y is equal to -1. So let's go ahead and distribute the 2, right, to each thing. Plus 3y is equal to -1. Like terms, 7y. I wrote an x. Didn't mean to do that. So in this case, we're going to have, when we divide by 7, we'll get y is equal to a -3. So since we have x is equal to 2 times -3 plus 10, x is equal to -6 plus 10, x is equal to 4. So my ordered pair is 4, -3, all right? We know that that works for this equation, but we want to check it for this equation. So is 2 times 4 plus 3 times -3. So 2 times 4 is 8 plus 3 times -3, -9. So -9 plus 8 is -1, so it works for the second. So this has one solution for -3, and we just found it easily by just doing the substitution. All right. Now, sometimes there's infinitely many. So here's a word problem, basically. It's showing you the perimeter of rectangle A is 36 units. The perimeter of rectangle B is 108. We're going to write and solve this. So knowing that you have, 2 times this side plus 2 times this side to equal the perimeter. So we've got these equations right here. So with this system, let's go ahead and do elimination. We just reviewed substitution. So let's do elimination. So in order to get, let's say we want to cancel the x's. Let's multiply by a -3. So we'll have -12x minus 24y is equal to, oops, let me grab a calculator here. 36 times -3 is a -108. And now we are going to go ahead and add, so the x's cancel, the y's cancel, and the 108's cancel. So we get 0 is equal to 0, kind of like that, right? And it's always true. If that's the case, then it must be the same line, and we know that there's infinitely many solutions. So if you recall, in one of the previous examples with no solution, we got a statement at the end that was not true. So that is why there's no solution. Here we get a statement that is always true. And again, by inspection, if we put them in slope-intercept form, they would be the same line. So let's go ahead and do that. I'm going to go ahead and just put these in. Well, actually, let's just do elimination, because look at this. The y's are already set up to cancel. So if we add, we get 2x is equal to 0. So x is equal to 0. So if we have 0 plus y is equal to 3, so y is equal to 3. So we should have 0, 3 as the ordered pair. Well, let's check this out. I'm going to change to blue. So we have a 0 here, and we have a 3. 0 plus 3 is 3. Is 0 minus 3 equal to -3? Yes. So we know that we have the solution because we checked our work. Okay. Looking at this problem, one thing we could do is, let's see. We could put it into slope-intercept form, right, pretty easily. So minus 2x on both sides. So the first equation would be y is equal to -2x plus 5. Here we have to subtract 4x from both sides. So we'll get 2y is equal to negative 4x plus 0 divided by 2 divided by 2. So y is equal to negative 2x, 0 divided by 2 is 0. So if you can tell right here that we have the same slope right here and right here, right? We know that there will be no solution because of the same slope, okay? I'm going to kind of continue this since we can put these into slope-intercept form. So I'm going to subtract my 2x from both sides. So I have negative 4y is equal to negative 2x plus 10. Then I'm going to divide by negative 4. So y is equal to 1/2 x. Ooh, let's simplify that a little bit. Let's say, okay, 10 and 4 are both divisible by 2. So let's do 5 over 2. No, okay. Now add 12x. So then I have 24. Y is equal to 12x minus 16 divided by 24. So y is equal to this is 1. So I have this 60 divided by 24. Let's see. 12 goes into both of them, right? So 5 over 2. Now look, I have 1/2 x minus 5 over 2 and 1/2 x minus 5 over 2. It's the exact same line. So infinitely many solutions. Okay? The other thing is if we would have solved it, like say, I don't know, maybe multiply the top one. Let's try it this way. Let's multiply the top one, do it 2 different ways this time, by a 6. So I would rewrite this as 12x minus 24y is equal to 60, right? And then I'm combining that with this, and we get that situation where we get 0 is equal to 0, which is always true. And that's another way to know that we have infinitely many. Okay, that concludes our notes.